Good morning. So today we're looking at domain and ranges from graphs. So there's a few important concepts you need to recall. The domain refers to the x values. These are represented in a problem. And the range refers to the y values that are represented in a problem. Sometimes it isn't possible to list all the values that x or y could be because the graph is continuous. That's when it's made up of an infinite number of points. Examples of these are lines, rays, or segments. In a continuous graph, to determine the domain, you should focus on looking left to right. In a continuous graph, to determine the range, you should focus looking bottom to top. We're going to use interval notation to help us describe the domain and range for graphs that represent continuous situations. So in example number 1, we have a continuous graph with two endpoints, endpoint A, endpoint B. So our domain goes from endpoint A to endpoint B. It is -7 less than or equal to x because it's closed, less than 5 because it's open. Notice that this graph has those two endpoints beginning and ending left to right. The range top is at 1 and the bottom is at -3. So our range bottom to top is -3 less than or equal to y all the way up to 1. So just an important piece of information. To find the domain for a graph with two endpoints, you always identify the x value farthest to the left and the point farthest to the right. For the range, you identify the lowest and then the highest. A continuous graph may sometimes only have one endpoint. So that means that it's continuing forever in the opposite direction. So here we have an endpoint at 0, 0, and our graph is continuing infinitely to the right. So our focal point is left to right, so it's x greater than or equal to 0, because every x value beyond 0 exists. Similarly, the range is bottom to top, so the lowest y value is 0, and again, the arrow is going up a little slower on y than on x, so its range is y greater than or equal to 0. Remember, we focus bottom to top. If the arrows were pointing to the left, so this way, the domain would be the opposite symbol. It would be less than or equal to. If the arrow were pointing down, then it would be less than or equal to for the y value. So that would be like pointing this direction. Sometimes a continuous graph may have two arrows. In this case, my domain, as long as it's continuous, is all reals. Again, focusing on left to right. Arrow left is going up, arrow right is going up. Both are continuing in opposing directions. So this indicates that the graph continues in the left direction forever and in the right direction forever. That means every possible value of x exists. So you can write x equals all reals. You could write -infinity to infinity. Now the range is a little trickier. Remember, bottom to top. So the arrows are pointing up, therefore my graph is continuing infinitely. However, it stops here at 0. So my range is the y values greater than or equal to 0 because it is continuing upward. Now again, notice if one of the arrows were pointing up and one of the arrows were pointing down, then the range would be all reals. So that would be like if this graph went here and then maybe down here. That would change my range to be all reals. but that's not the case. Therefore, my range is not all reals. So again, it's lowest to highest, paying attention to our arrows and identifying those domains and ranges. Okay, have a wonderful day and now practice on your own.